Hey folks, Professor Gray here. Ready to talk to you about confidence intervals, and in particular, proportion confidence intervals. I'm going to show you how to make a proportion confidence interval with minimal calculator help, and then we'll go back and redo our work with the calculator as well. Well, to make a confidence interval, we use a point estimate, PE for short, and a margin of error. And the point estimate is the number or the value in the middle of this range or interval. The margin of error is how much we spread out on both sides, to the left or right. One way to write the confidence interval when we have it completed is to put the symbol for the parameter in the middle. For proportion, that would be a lowercase p. On the left, to put the value, that is the point estimate minus the margin of error. To the right, to put the point estimate plus the margin of error. To construct a population proportion confidence interval, we use a particular formula for the margin of error. E is the margin of error. It's z sub alpha over 2 times the square root of p hat times q hat over n. P hat is the sample proportion. Q hat is the complement of the sample proportion. So 1 minus the sample proportion, or 1 minus p hat. And n, of course, is the sample size. Z sub alpha over 2 is the critical value associated with the confidence level, which we talked about earlier. Let's do an example. In a study of 1,228 randomly selected medical malpractice lawsuits, it's found that 856 of them were later dropped or dismissed. So let's find the point estimate for the proportion of dropped or dismissed lawsuits, and we'll use a 99% confidence level to construct a margin of error. We'll use that to make a confidence interval, a 99% one, as a matter of fact. And then we'll analyze our results and determine if the majority of such lawsuits are dropped or dismissed. For number 8, to find the point estimate for the proportion of dropped or dismissed lawsuits, we simply use the sample proportion, that's p hat. In this case, that would be 856 dropped or dismissed lawsuits out of the total 1,228. If I use the calculator to find the decimal equivalent of that value, I find that it's approximately 0.6971. That's the point estimate. If we're only going to pick one point or one value to estimate the population proportion, the best thing we can go by is the sample proportion, that's p hat. Number 9 says, using a 99% confidence level, what's the margin of error? Well, for this we'll use the formula that was on the previous slide. E is z sub alpha over 2 times the square root of p hat times q hat all over n. And we'll substitute in and find our margin of error. Well, the first thing to substitute in is z sub alpha over 2. Z sub alpha over 2 is the critical value associated with a 99% confidence level. If I take a look on my positive z-score page down at the very bottom, common critical values, I find that a 99% confidence level is associated with the critical value 2.575. So z sub alpha over 2 is 2.575. Now for the rest, p hat was found in number 8. It's 0.6971. I'm want to multiply that by q hat, which is 1 minus p hat. Over here on the side, I can find that. Well, 1 minus 0.6971 3029. So q hat is 0.3029. And I'll divide that by n, which is the sample size. In this particular problem, the number of lawsuits is 1,228. Well, as long as I'm mindful of the parentheses, I can put this in the calculator on one line, 2.575 times the square root of. Now, you'll notice that if you have a TI-83 or a similar calculator, you get one parentheses and open parentheses after you open the square root button. So within that parentheses, I'm going to open another parentheses, 0.6971. Close that parentheses, open another, 0.3029. Close that parentheses, divided by 1,228, and then I'll close the parentheses one more time. That closes the original one that was open with the square root. When I press enter, I'll get my answer, and there it is. That's my margin of error. We'll round it to 4 places since this is a proportion. So the margin of error is about 0.0338. That's my answer for number 9. Number 10 says, well, let's use this information and we'll construct a 99% confidence interval. All right, well, when we make a confidence interval, the lower part of that interval, the lower bound, is p hat minus e. That's less than the parameter p, which is less than p hat plus the margin of error. Substitute those in, 0.6971 minus 0.0338. I leave the less thans and the p in the middle. Now 0.6971 minus the margin of error. That gives me my left value, my left bound. And when I add, I get the right bound. This is my answer. Now, occasionally you may see this written in something called interval notation. It's good to be able to recognize what interval notation means when you see a confidence interval in it. So another way of writing that is like this. That looks like it's a point, but it's not. That's actually an interval. The strictly less thans are illustrated by the curved brackets, and there's a comma between the two numbers. So I can see that written in one of two ways. One way that you will not see that written, however, one way that's incorrect, is to mix those two notations like this. That mixes the two notations, that is incorrect notation. So either the first one or the second one, but we do not combine the two. That's my confidence interval. An interval between 0.6633 and 0.7309 is a 99% confidence interval for the true proportion of medical malpractice lawsuits that are later dropped or dismissed. All right, number 11 asks us to apply this information. It says, does it appear that the majority of these lawsuits are dropped or dismissed? Well, a majority would be anything above 50%, or 0.5 as a decimal. And as you can see, with the confidence interval we made, we are 99% sure that the true population proportion is at least 0.6633, which is much larger than 0.5. For those reasons, yes, it looks like most of them are dropped or dismissed. We could speculate on reasons for that, but those are what that is what the numbers say. Well, let's do this confidence interval one more time, this time using the calculator exclusively. To do so, I go to Stat, Test, and the calculator command for a proportion confidence interval is letter A on my calculator. It's 1 prop z int. That stands for 1 proportion z interval. Now the z is for normal distribution, so this uses a normal distribution, just like we had a z sub alpha over 2 in the formula for the margin of error. So proportion confidence intervals are done with stat, test, and 1 prop z int, 1 proportion z interval. If I press enter, I have some things to fill in. X is the number of occurrences. In the sample. N, as usual, is the number of trials or the sample size, however you want to think of it. They are the same in this context. And C level is the confidence level. So for this particular problem, there were 1,228 randomly selected medical malpractice lawsuits. All right, the occurrences, the ones that were dropped or dismissed, is 856. That's X. N is the sample size or number of trials. That's the 1,228. And the confidence level, well, if I look at number 10, construct a 99% confidence interval. That's 99%. And I can type that in as 0.99. When I have all that in, I go to Calculate and press Enter. And I get something very similar to the answer I have for number 10. At the very top, right under the words 1 prop z interval, I have my confidence interval. If I round that to 4 places, again, I get 0.6633 to 0.7309. In interval notation, the calculator uses that. Underneath the confidence interval, I have p hat, which we found in number 8, and it restates the sample size. So that's how you can use 1 prop z interval to find confidence intervals for proportions in the calculator.